Okay, let's take a look at number 11 in section 2.7. I'm going to find the horizontal asymptote or asymptotes potentially of this function here. And parenthetically, again, use symbolic notation, fractions where needed. If there's more than one horizontal asymptote, you would give them as a comma separated list. Okay, so you would list each one separated by a comma. Now remember, y equal L is a horizontal asymptote of the function f of x if the limit as x goes to infinity of f of x is L, or if the limit as x goes to negative infinity of f of x is L. And so remember, a horizontal asymptote is a horizontal line. So it has an equation. It's always of this form, y equal some number, right? So a horizontal line at some constant height, y. Um, and so notice you can have, for some functions, you can have different limits as x goes to infinity versus x goes to negative infinity. If both those limits exist, you can have up to two horizontal asymptotes, and that's this whole thing about give them as a comma separated list. Turns out this function has only one horizontal asymptote, but there are functions that have two. Okay, so let's proceed. We are going to proceed not knowing whether we have one or two or no horizontal asymptotes, and we'll just take the limit as x goes to infinity, and then x goes to negative infinity of the function. It's pretty easy to do. Hopefully you remember there's a couple ways I showed how to do this, but as x goes to infinity, the form of the limit, first of all, for this function, 7x cubed minus 9x squared, well, that's going to go to infinity. You think about the end behavior for this polynomial function, it's going up to infinity as x goes to infinity. This one here is a opening downward in a sense, as x goes to either negative infinity or positive infinity, because look at the highest degree term is negative 5x to the fourth because of the negative coefficient that's going to negative infinity. Doesn't really matter though whether it's positive or negative infinity. This is an indeterminate form, right? Infinity over infinity. So what can we do to evaluate it? Well, remember, we talked one way is look at the highest degree term, the highest degree power rather of x in the denominator. That's x to the fourth. What I'm going to do is I'm going to divide both numerator and denominator by x to the fourth. We can do that because x is going to infinity, so we would never be dividing by zero. And then I'm just going to divide, right? 7x cubed divided by x to the fourth is going to be 7 divided by x, right? X cubed over x to the fourth will leave 1x in the bottom. 9x squared divided by x to the fourth will be 9 divided by x squared. Down here, 7 divided by x to the fourth is 7 divided by x to the fourth. 9x divided by x to the fourth is 9 divided by x cubed. And 5x to the fourth divided by x to the fourth is 5. And so this is the equivalent expression as x goes to infinity. And remember what we know, as x goes to infinity, 7 divided by x, that's going to go to 0. 9 divided by x, that's going to go to 0. And so all these are going to 0, and you're just left with what? The form of this limit is 0 over negative 5, which is not indeterminate. That's equal to 0. And so notice we have one horizontal asymptote for sure of y equal 0, right? Because the limit is 0. Another way you could evaluate this limit, by the way, is just take the highest degree term up top, which is 7x cubed, the highest degree term in the bottom, which is negative 5x to the fourth, and the limit of this rational expression will be the same as the limit of this rational expression, where I just take that highest degree term up top and the highest degree term in the bottom. Simplify this. What do I get? Well, x cubed divided by x to the fourth leaves 1x in the bottom. And what's happening to this, again, as x goes to infinity? Well, it's going to 0 because the form of this limit here is, I guess we could say negative 7 over infinity, right? And as you divide negative 7 by something getting bigger and bigger, 10,000, a million, a billion, that ratio is going to 0. So, of course, we get the same thing either way in this case. By the way, if you take the limit as x goes to negative infinity, it would look the same. I do the same operation, I get to the same thing. But as x goes to negative infinity, all these fractions go to 0 as well. Okay. And so the same effect, right? We get the same limit, which means there's just one horizontal asymptote. The function approaches the same horizontal line in both directions. So the equation of our horizontal asymptote, since our limit is 0, is y equal 0. And it's important to write it as y equals 0 and not just 0. You're going to get an error right for that because it's the equation of a horizontal line. Okay, hope this helps.